Hey everybody, sorry I can't be with you today to help you through this assignment, but wanted to take a moment and point out a couple of points where I think people may get hung up on. Looking at your remote sensing ices on Mars assignment, the big thing to look at is you're looking at three major types of data. You're looking at visible light, infrared light, and gamma rays, and they're going to tell you certain different things. So if you look over at this chart, visible brightness, all your different types of ices, water, carbon dioxide, ammonia, and methane, all appear bright. So visible light's simply going to show you the presence of some sort of ice when you're looking at that. The infrared light will give you different temperature values, and so they show the Martian frost point temperatures there, and you can see negative 75 for water, negative 123 for carbon dioxide, around negative 200 for ammonia, and around negative 220 for methane. So if the temperature gets colder, at that cold or colder, we see the presence of those ices. The last type of data, the gamma rays, can penetrate deeper into the Martian surface, and so they show us the presence of hydrogen, which is present in water ice, not carbon dioxide ice, but they show us the presence of hydrogen, which can be subsurface, because on Mars, ice can exist subsurface. And so, view of my lovely foot there. We look, this is our visible data from the North Pole in winter and the North Pole in summer, and you can see the changes. When you get to, this is the one I think confuses people most sometimes. The lines on here show where that temperature would exist. And so if you look at it outside of the line for negative 120 degrees Celsius, the temperature would be warmer, so it's somewhere, more than negative 120. Inside of that circle where it's darker, that means it's colder than negative 120. So if you'll remember, the carbon dioxide ice forms at around negative 123. Pretty much outside of that line, you wouldn't have it, but inside of that line, it can be anywhere from negative 120 to negative 140. So inside of that line would indicate the presence of that ice. And you'll see that changes from the contour line for summer is negative 70 degrees Celsius. When you're looking at the gamma rays, just notice it's the they don't give you a specific value that shows it, but you see that the gamma rays are less intense in winter and more intense in summer. Now, looking back at some of the other changes that occurred, such as in your temperature map from the infrared data, you might notice that it still stays colder, so it's not like the water ice is going to disappear in the winter. So something else has to be happening, and typically that might mean that it's, but yet then we see it in summer, so something is blocking that signal between the two. Anyway, hopefully this helps somewhat. If not, I did start a discussion where you can ask questions in the Canvas classroom. Please feel free to do so, and I will try to get back to you in a timely fashion. Hope you all have a great spring break. Bye.